Hello everyone. As Karine said, I'm Kevin Godin-Dubois, and today I'm going to talk about actually two things. The first one is not necessarily something completely new, as you will see, artificial general creatures. It lies upon a lot of things already done in artificial life, but it tries to put them in some more formal light. And the second one is kind of an extension of this triangle of life thing that we've seen a few times today, and that relies on interactive evolution. So to start off with what I mean with artificial general creatures, let's start with the what, and then let's move on to the how. So the definition I give here is that artificial general creatures would be robotic or virtual agents that have the capabilities to ensure their own survival. So the definition is broad, very broad indeed, but it encompasses some very important characteristics, namely to be able to sustain themselves or to reproduce. Those creatures would be, in this definition, called artificial general creatures. Every other creature would be called prototypes or something interesting, but that doesn't exhibit those interesting characteristics. So to put things into perspective, let's look at things that we know from previous research. For instance, Deep Blue. So it's a computer and a software that is capable of winning at chess. It won against a world champion at its time. And on this completely arbitrary coordinate system, I would say that it has some great performance because it was capable of, again, beating a human at a complex game, but it's got no autonomy. It's just a big box, a functional box that does something, but it is not capable of doing anything besides playing chess. On a larger scale, we have the reinforcement learning agent from NI, if I'm pronouncing that correctly, that plays a lot of Atari games. So it's a more complex space because now you have different kind of situations and you have different kind of actions. So they have, I would say, a higher kind of performance. They are capable of doing more things, but again, they are disembodied agents. They are, could say they have an eye and a hand, and that's it. What would be on the upper layer of that performance would be, for instance, a GPT, which is capable of handling yet even more different kind of inputs. So we are not limited to images now. We have very huge images. We can have text, etc. So for instance, GPT is capable of recognizing why someone ironing out their clothes while on a moving taxi is funny. What does it give us as an information? Does it understand that it's funny because it can relate it to the real world or because it has amassed information about what people find funny? That's an open question. But the fact is that even if it's capable of recognizing that, it's still a disembodied agent that is not capable of doing anything besides answering questions. So, sorry. Let's look at the other side of that scale. In terms of autonomy, I would say that one of the simplest creature that can satisfy the minimal criteria of sustaining itself or reproducing could be the creatures from Conway's Game of Life. So the glider is definitely not a complex creature. It's not capable of doing a lot of things except one, sustaining itself. By solely existing in a system where the rules say that this specific shape will continue and it would keep on existing, it keeps on existing. So it is autonomous without making any effort to be so. A more complex case would be the real-world spontaneous reproduction from the Robot Baby project, which you already heard of. So in terms of performance, they are capable of doing more things. Basically, they have to move around in the environment. So they are way more complex on that front from Conway's creatures. However, even though they are capable of spontaneous reproduction, it is an assisted reproduction because the human is still there in the loop to place the robot in the arena to actually do the reproduction itself. And what I would place on the rightmost side of that Scale would be digital organisms. So for instance, those from Avida or Tierra, because those individuals live in a closed environment in which they have full control over everything. And what do they have to do in that environment? Well, they have to survive. They survive by actively doing something in an environment that's not really simulated. It's only done so because it's a computer program. So obviously it's going to be on a computer, but they have full control over everything and they need to ensure their survival proactively. So let's clean up the graph and summarize everything. Artificial intelligence is mostly concerned with the performance of its agents. Artificial intelligence wants to make creatures, or more specifically agents, that would do something and would do it very efficiently. The autonomy of the agents is more of a side effect, sometimes a desirable side effect that would be actively sought, sometimes it's an afterthought. Artificial general intelligence would tend to be placed on that upper part of the graph. So artificial general intelligence would be an artificial agent that does something or many things very well and that may have some level of autonomy. On the other side of that graph, we have the artificial creatures. Those creatures tend to do things by themselves. So being a glider and just gliding around, the virtual plants that reproduce in simulated environments, evolutionary robotics that try to sustain themselves, all of those are creatures based mostly on the autonomy that they exhibit rather than on the performance. And the artificial general creatures, of which I'm talking about, would be placed on that rightmost part of the graph. These would be creatures that are concerned mostly with their autonomy, being able to sustain themselves, being able to even reproduce. And the performance would be a very desirable side effect, because if they cannot do anything, that wouldn't be very interesting. But the driving mechanism would be the autonomy itself. So now that I've given you a definition and some example to help you understand the frame of mind in which I approach the subject, let's talk about how we could get to that point. So, evolution. We have a population generated randomly, and we evaluate it, we select the best one, and we start over and over and over and over. If we change that graph slightly and add a neural loop, then we have the triangle of life, where the agent will be able to learn things during its lifetime and be potentially better. And all of that happens, can happen only in simulation, can also happen in the real world. But for now, in this context, let's say we only work in simulation. What we could do is that instead of a completely predetermined algorithm where we select the agents based on some heuristics or multi-objective criteria, we could do a preselection in combination, and that preselection could give us a sample of the creatures that are promising according to whatever criteria is pertinent at the moment, and that this preselection could be shown to a human participant, not necessarily an expert, not necessarily someone that is knowledgeable about artificial agents, but just some regular human, someone who just happens to be in the lab. This agent could then select, based on their subjective view of what is important in a robot, a subset of that preselection, which could then be fed back into the evolutionary algorithm. The advantage of that is that you can drive the evolution towards new areas because you have selected your agent based on new criteria. So it also won't help escaping the local minima of optimization. But then if you have the appropriate platform, so as we've seen today, we have a few platforms now that can be used to create in the real world something that you have simulated. So you could take that robot that has been selected by a human and actually physically assemble it. Then, because it's in the real world, that same human could actually interact with it. And by interaction, I mean that there will also be some learning. First, because we have heard that it can help with the reality gap. Now, the robot has some stuff that is slightly different, so it needs to readjust to that, but also to learn about the other agent in the environment, namely the human. What is the human trying to get it to do? And then, based on that interaction, we can once more have some feedback into the evolutionary loop. Or if we already have something promising, we can actually have a deployment. And in that way, we have a solution to get individual artificial creatures that are more autonomous if the human agent is putting the accent on that autonomy. So that links back to what I said previously. What if we teach the agent to first be self-sufficient, and then we teach it to actually do something with that knowledge? So when I initially prepared those slides, I was thinking that I would present it a bit earlier and that you will all be in the best of disposition, but I'm sure you still have some energy in you. So for those who have a computer, I'm going to skip to that in the meantime. I actually have a Mentimeter for you to play with. For those who have a phone, there's a QR code if you actually can scan it. On there are three big questions. So, artificial general creatures, as I've described, have a very broad definition in which I stress 2 points: reproduction and sustenance. Do you think there are other important criteria to take into consideration? The challenges of getting artificial general creatures, on the top of my head, I can think of actually fully automatizing the printing process, which has been done in a few instances, and also some other problems like evolving organs, like how do you create something totally new, a new brick, for instance, of a specific dimension, and now you need a microphone. How do you solve that? And the applications. And while you are thinking about that, I'll get back to the previous slide. So artificial general creatures, to summarize, what are they? In my definition, self-sustaining creatures, like the one that can be created from Evosphere, if I'm not wrong. And how to get them by virtual to real mapping. So I'm stopping there early, and hopefully the Mentimeter will be full by the time we're at the end of the question. Thank you for your attention, and please ask questions and fill the Mentimeter.